Hello. In the last video, you saw an example of calculating the mean, or the arithmetic average, using a frequency distribution. At the beginning of our series, you saw how to calculate the mean with an array of data, simply by summing up the values of the variable, x in this case, divided by the total sample size, or n. With a frequency distribution, we're going through the same process, but because we're using a table, we're going to multiply the value of x by the frequency first. Then we'll sum up those products and we'll divide by n. To give you an example, let's create a frequency distribution here for a variable called z. And we'll say that z takes on values of 10, 20, 30, and 40. And we have a frequency distribution that looks like this: 2, 4, 5, and 2. So our sample size is going to be 2 plus 4 is 6, plus 5 is 11, plus 2 is 13. We've got a total sample size of 13. Now, to create our average, or calculate our average, we're going to take this table and we're going to first calculate a new column called x times f. Now, this is in our numerator for the calculating the mean, and we need to multiply each value of z. I guess in this case I should call this z times f, right? And that our formula up here would be z times f. So we can multiply the value of z times the frequency, and so we'll get 2 times 10 is 20, 4 times 20 is 80, 5 times 30 is 150, and 2 times 40 is going to be 80. Now we can add up this column because we have to get the sum, right? Our formula says take the sum of x times the frequency, or in this case z times the frequency. And so we'll take 20 plus 80 is 100, plus 150 is 250, plus 80 is going to be 330. And that's going to equal the sum of z times f. Okay, so we've got the sum of z times f. Now we've got all the information that we need to calculate our average. If we start with our formula here, we've got the mean, the sample mean, x bar, is equal to the sum of z times f divided by our sample size. So the sum of z times f is going to be 330 divided by, and then our sample size is 13. So we'll get 330 divided by 13, and that'll give us an average of 25.38. 25.38. So somewhere in here between 20 and 30, we've got a mean which is 25.38. And we can visualize this if we want here by creating a frequency distribution, and creating a histogram of this frequency distribution where we've got our values of x. We've got 10, 20, 30, and 40. And we'll create our histogram using the frequencies here. And we'll say we have 1, 2, 3, 4, and 5. So there were 2 10s in our frequency distribution. There were 4 20s. There were 5 30s. And there were 2 40s. Okay, and so we've got this distribution. It looks kind of normal, but it's a little skewed. It's got some negative skew. The peak seems to be pushed over a little bit towards the left here, and we seem to have a little bit longer left-hand tail. So, but other than that, it's kind of normal. But we can plot this average here. Now our mean is 25.38, And so we'll say it's about halfway between 20 and 30, and we'd put our average here equal to 25.38. And so here you can visualize the mean in this distribution. Because the peak has been pushed over a little bit to the left, or to the right, and that we have a little bit longer left-hand tail over here, that the mean gets pulled a little bit further towards the left-hand side. So it doesn't sit squarely in this peak at 30. It gets pulled down a little bit, and the mean is 25.38. So this is just another example of how to calculate the mean, or the arithmetic average, using a frequency distribution table and making a slight adjustment to our mean formula.